is Zulaikha, and together with Nazura, we will be presenting our project titled Building a Real-Time Sensor Data Monitoring System with Node-RED. This presentation is part of our Advanced IoT Systems course under the Diploma in Electronic Engineering, Internet of Things. Project Overview: The Flow of Data. Our project captures, processes, and visualizes real-time environmental data using Node-RED, a flow-based programming tool. The data starts from a physical sensor, passes through the Node-RED server for processing, and is finally displayed on a web dashboard. This architecture provides low latency and easy accessibility, making it ideal for academic projects and rapid IoT prototyping. Purpose: accessible, real-time monitoring. The main goal of this project is to build a simple and user-friendly system for monitoring sensor data in real time. It allows users to view instant feedback as data is generated, provides visual clarity through charts and gauges, and demonstrates how Node-RED can be used for quick IoT prototyping. Key components and tools. For this project, we used several key components. Node-RED acts as the core platform for wiring devices and processing data. Physical sensors, such as the DHT11 or DHT22, collect temperature and humidity data. An MQTT broker handles the communication between the sensors and Node-RED. Finally, the dashboard nodes create the user interface that visualizes the data in real time. Node-RED flow, logic and processing. This slide shows our Node-RED flow. First, the MQTT input node subscribes to sensor topics and receives raw JSON data. The function node then parses and extracts the temperature and humidity values. Next, the switch or split node routes the data to the right visual elements, such as the line chart for temperature and the gauge for humidity. Lastly, the dashboard output nodes send the processed data to the web interface for display.
Dashboard design: visualizing data. Our dashboard was designed for clarity and usability. Line charts display temperature trends over time, helping users spot changes or anomalies easily. Gauges show real-time humidity levels for quick reference. We also included text and history tables to display exact values and recent readings for more detailed analysis. Visualizing the pulse of the system. Here we emphasize that visualization is key to understanding data. By combining line charts, gauges, and tables, our dashboard provides both instant and historical insights, giving users a complete picture of system performance. Challenges encountered and solutions. Throughout development, we faced several challenges. First, inconsistent sensor readings caused data noise. We solved this by adding a smooth node to filter the values. Second, MQTT payload formats didn't match, so we used a function node to convert them into standard JSON objects. Third, our dashboard didn't display properly on mobile, so we optimized it with groups and containers for better responsiveness. Lastly, we debugged asynchronous data flow using debug nodes placed at key points to trace errors effectively. Challenges encountered and solutions. Throughout development, we faced several challenges. First, inconsistent sensor readings caused data noise. We solved this by adding a smooth node to filter the values. Second, MQTT payload formats didn't match, so we used a function node to convert them into standard JSON objects. Third, our dashboard didn't display properly on mobile, so we optimized it with groups and containers for better responsiveness. Lastly, we debugged asynchronous data flow using debug nodes placed at key points to trace errors effectively. Key takeaways: lessons learned. From this project, we learned several key lessons. Node-RED's flow-based approach helps speed up development and makes complex data pipelines easier to manage. We also learned that pre-processing data is essential to ensure accuracy before visualization. Lastly, we discovered how valuable the Node-RED community and documentation are when building IoT systems.
Future improvements and next steps. Our current system provides a strong foundation, but there is still room for enhancement. In the future, we plan to implement alert notifications via email or SMS when sensor readings exceed predefined thresholds. We also intend to integrate a database system such as InfluxDB to enable efficient long-term data storage and retrieval. Additionally, we aim to introduce remote control functionalities, allowing users to turn devices on or off directly from the dashboard. Finally, we plan to explore containerization using Docker to simplify deployment, improve scalability, and ensure consistent performance across different environments. Thank you for watching.